Okay, this is a recording of notes for 1-8 for 6th hour geometry. And I'm just going to go through the original slides again from yesterday. And this is three-dimensional figures. Our essential question is, can you identify name, find surface area, and find volume of three-dimensional figures? Hopefully yesterday you wrote your level of understanding and you did that little identifying solids activity. And then we went over those solids. So just as a little reminder, and I will turn the lights off. Number 1 was a sphere. Number 2 was a hexagonal prism. 3, triangular prism. 4, cone. And then square prism, excuse me. And then the second set was cylinder, cube, square pyramid, triangular pyramid, and hemisphere. Just give me a head nod, you know, after you saw them at least, was that all pretty familiar to us from our previous work in geometry topics. So yesterday in 6th hour, we instead of writing these definitions in our key terms page, we are we're having them on the handout and just kind of underlining important things. So a solid with flat surfaces that enclose a single region of space is called a polyhedron. The flat surfaces are faces. The line segments where the faces intersect are called edges. And the point where 2 or more edges intersect is called a vertex. And so I have kind of some bigger ones to look at today. If you're on the tour of engineering, then you are missing out on seeing the solids that we have to look at today. So this I would call a square prism. The top and bottom are squares, and these are the bases. And it has 6 sides. 1, 2, 3, 4, 5, 6. It has 6 sides that are all faces. All 6 of these are faces. These 2 are additionally bases, but they are still faces. The edges are right along here, and the vertices are kind of those little points. So we know all about those ideas. Then we have 2 different kinds of solids that we generally look at. Polyhedrons, and polyhedrons are a prism is a polyhedron with 2 parallel congruent faces called bases connected by parallelogram faces. As a matter of fact, in the state of Minnesota, and maybe you wonder why I say that. Oh, this is the only hour I'm saying this on my recording. Because I'm actually not from Minnesota, but in the state of Minnesota, these are our state standards. I'm from Baltimore, Maryland originally. And so, do you agree, look at these carefully, that these are both triangular prisms? Give me a little head nod on that. They are triangular prisms. But this one is oblique, is the math word for that. This one's oblique and this one's right. And right means that with the ground or with the bottom, this makes a right angle. And so these sides that go up and down between the bases are all rectangles, correct? And the reason the book authors say parallelograms is because it could be oblique, and the book is written for, you know, anybody in the United States. And we focus in Minnesota on right prisms. So it's a polyhedron, and it has 2 parallel congruent faces called bases, and it's connected by, it says parallelogram faces, but ours are going to be rectangles. The other reason I comment on that is there might be oblique pictures in our homework activities, and so if there is, you would omit those, and I shouldn't have assigned them. A pyramid, same kind of idea. It's a polyhedron. It has a polygonal base, and it has a base, so it's only 1, and 3 or more triangle faces that come up to meet at a common vertex. And so for the triangular pyramid, it has a triangle on the bottom, and this is maybe a square pyramid, it has a square on the bottom. But notice this, the bases are triangles and squares, but the other faces that kind of go up to that point, they're all triangles. No, even if this is not a triangle on the bottom, that those are triangles as we go. So that is a pyramid. And then things that are not polyhedrons, but we are super versed in them, are cylinders, cones, and spheres. They were all on our picture thing yesterday. Cylinder, solid with congruent parallel circular bases. And I'm just going to do that, connected by a curved surface. And so again, that makes it not a polyhedron. And then a cone is a solid with a circular base connected by a curved surface to a single vertex. And so just a reminder that we want to be, did I give you these? Okay, we want to be highlighting or underlining as we go through those handouts in class today. And then a sphere is really has a similar definition to a circle. If you remember, a circle is in a plane or a flat surface, all the points equidistant from a given point. Well, that's what a sphere is, except it's all the points equidistant from a given point in space. So you're not bound to just a single flat surface. So the set of points in space that are the same distance from a given point. A sphere has no faces, edges, or vertices. And then next is our little list of polyhedrons that are named. It's not every polyhedron that ever existed, but it gives us an idea of what we're talking about. And I just want to make sure that you're careful about this. If this lays this way, the base is not the bottom. The base has to be the two things that are the same shape. And especially if the two things that are the same shape are not rectangles. For this one, and I don't have the bottom on it right now, but for this one, the bases could be these two sides, or the bases could be those two sides, or those two sides, because they're all rectangles everywhere, and that would work out. But otherwise, we just have to find the bases. This is a hexagonal prism, and we have to find the bases that have the same shape, and then the other faces are all rectangles as we go. So I'll just read through those: triangular prism, rectangular prism, pentagonal prism, triangular pyramid, rectangular pyramid, pentagonal pyramid. And so those are just general polyhedron. There are some special polyhedrons that are regular polyhedrons. And remember, a regular polygon is a polygon with all the angles and the sides the same. Well, this is a polyhedron, so it's three-dimensional, and all of its faces are regular congruent polygons, and all of its edges are congruent. And there are exactly 5 of them. That is it. In the world, there are 5 regular polyhedrons. They are called platonic solids. That's just a piece of information for you. I'm not going to quiz you on that, but you can see the word Plato in there, and so Plato used them extensively. That's why they're called the platonic solids. And that also should tell you that we've known about them for a long time. There are 5. You are expected to know 2 of them by name. And so one of them you have a name for already. The first one is a tetrahedron. It is 4 equilateral triangle faces. And I do not have a tetrahedron. Nor do I have the bottom of that little guy. But I do have, let me find, okay, I do have some triangular pyramids. So look at this one. Hopefully you agree this is not a tetrahedron. It's a triangular pyramid, but it's not a tetrahedron. That is an equilateral triangle. Do you agree? It's an equilateral triangle. But these are not equilateral triangles, correct? They are the same as each other, but they are not equilateral triangles. So that's pretty easy to tell. This one also is not a tetrahedron. See, this is the bottom. I took it off. The bottom is an equilateral triangle, just to let you know. But if I take that off and kind of set it here, because these don't look that much different, but I just want to make sure you agree that the ones that are the faces coming up to the vertex are not exactly the same as that bottom. So this is not a tetrahedron also. I actually don't have any, just nice little nifty tetrahedrons. So I just want you to know, though, that you are expected to know what a tetrahedron is. The other thing you're supposed to know what it is a cube or a hexahedron. And think about the word or the prefix hexa, like a hexagon. That means 6, correct? Well, what is a cube? It has 6 squares. Do you agree? It has 6 square faces that are all the same. And then 2 of those are also considered bases as we go. Now, the other 3, I'm not going to tell you that you have to know. But these, if you see the word, usually it'll be cube, but hexahedron or tetrahedron, you're expected to know what those are. And so this is an octahedron. It's 8 equilateral triangular faces, and octa means 8. A dodecahedron is 12 regular pentagonal faces, and an icosahedron is 20 equilateral triangular faces. And so that's by taking regular polygons, all the same regular polygons. How many of them does it take to kind of make a solid shape? And this is kind of what we get from that. The next handout is about surface area and volume. This is considered review, but I do like to go over it a little bit in class. So surface area is a 2-dimensional measurement of the surface of a solid figure, and it's a bunch of areas put together. The surface area is the sum of the areas of each face. Now, I'm just going to remind you that if I had this solid figure, do you agree that I could find, if I had enough dimensions, I could find the dimensions of all of these things, and I could find the area of this, area of this, area of this, area of this, and the area of this, and I could figure out what that total area was. Well, we have kind of an easier or some shorthand things. Just a reminder, and if you're new to this, you get to use your notes when you take quizzes in here, but when you take your test, you don't get to use your notes, but you'll be given a half sheet of paper that you can write formulas and things on. The 11th grade formula sheet that's in the front of your notebook has some of these formulas. Any that aren't on there, or on the 11th grade formula sheet, they're not super labeled, like what it exactly is for. You might want to write some of these on your half sheet of paper. When you take your next quiz, you'll have access to this in your notes. When you take your next test, if you want access to anything, you'll have to write it on that half sheet of paper. And then volume is the measure of the amount of space enclosed by a solid figure. And I just want to take a moment, hopefully you have a little room to write here, or you've glued this in maybe on your notebook as well. I'll try to pretend I'm getting it fit in right here. But I just want to have a little reminder of what kind of units we give, because now I am taking points off if you don't have the correct units and on your quizzes and things like that. So when you find perimeter, and this is from a couple of lessons ago, you use units. And so, feet, inches, centimeters, meters, whatever it happens to be. When you're finding area or surface area, it's units squared. And when you're finding volume, I'll just write VOL. It's units to the third. And that's because you're taking a dimension times another dimension as you look at that. And I I'm a believer in, not just saying here's the formula and using it. To me it's important that we know why the formula is there and how it came about. So I'm not going to talk in detail about all of these, but I am going to talk a little bit about a couple. If I wanted to find the surface area of this square prism, I could find the area of the top, double it, right? Because there's two. I could find the area of this one, and then I could, since it's square, these rectangles are all the same, and I could multiply it by 4. So I might actually do that, if I were doing this problem. But in general, I want to think about the fact that I could, if this were wrapped, and I could unwrap it or unfold it. Do you agree these 1, 2, 3, 4 things, if I wanted to just draw them by themselves, pretend that I'm drawing them all the same size, because I know that's hard for me. Does everybody agree if I took these faces and I unwrapped it, it would look like that? Just give me a little head nod quick. Yep. And if I wanted to tack on these, I could maybe put one of them there. Oh, that was worse than any I've done today. And there's my 2 squares, correct? So when we're finding the surface area of a prism, instead of finding all these separate areas, if we think of this then as a big rectangle, this side is the perimeter of that base, or the distance around that base, and then this is the height of the prism. And that's how they get this surface area is perimeter times height plus 2 times capital B. Capital B stands for the area of the base, and once you find one of them, they're both the same. And a couple things I just want to remind you of. See that capital B? That stands for the area of the base, because remember, I have these 3 prisms in my hands. Do you agree that this formula can be used for any of these 3, correct? But this capital B is the area of the base. Capital B is the area of the base. That is a hexagon. That's a square, and that's a triangle. Do you agree that to find the area of the base of each one of those, we have to use different formulas, right? And so that's the thing to be aware of as you go. So S is for total surface area. P is for the perimeter of the base. And that's just a quicker way to do it. You could find all those areas and add them together. And then volume is the area of the base, kind of filling that bottom, and then timesing by the height, each of those, so that it kind of comes up through and fills the rest. The other things you need to know about in this formula, remember the area of a triangle is 1/2 base times height, right? And so if you look at this triangle right here, and I'll draw in it on yellow, and then I'll get rid of it. That triangle right there, this is the base of that triangle. That's none of these capital B's, and it's never really listed as a base. But that's the base, and the height would be up like that. And keep in mind, that height of this triangle is not perpendicular. It's slanted, and so that's called L, the slant height. And so it's used when you're finding the area of these triangles that are there. This one doesn't have triangles in the other spaces. So there's 2 heights you have to be aware of, and I'll use these little ones to kind of to see this. So here's my triangular pyramid, correct? My pencil is the actual height. Do you agree? Well, if it wasn't wobbling around like that. The pencil is the actual height through the center. The slant height is exactly what that. It's kind of slanted along the side. And those are not the same length. As a matter of fact, give me a head nod. Do you know which one is longer, the height or the slant height? Just give me a head nod if you think you know which one is longer. It would be the slant height, because we could make a right triangle going straight down, straight out, and then like this. So that slanted height is the longest of those heights. And so then we have the formula for volume, and the volume is 1/3. And, we don't want to think that's a made-up thing. I'm not going to use this as an example. I'm going to use cylinders and cones. Just a reminder, if this was a can of soup, if you take the label off, what shape is it? What shape is the label? It's a rectangle, right? And so I'm going to pretend I took the can lid off, and there's the rectangle, and just pretend those are the same circle. And so if I want to find the surface area, I have to find the area of this, and that length along there is really what was wrapped around that circle, and that is the circumference of the circle, 2 pi r. And so that's that dimension, and when we multiply it by the height, we'll get that area. The area of a circle, pi r squared, and so there are two of those, so it's 2 pi r squared. Volume, the area of the base, which is, so really, we almost wouldn't need a new volume one because it's the area of the base times the height. Well, circle, the area of the base is pi r squared. And then we have this one for volume of a cone, and that is 1/3 the volume of the comparable cylinder. Do you agree with that? And so if I filled a cone with water and I put it in a cylinder and they had the same height and the same circles, how many cones will fit in a cylinder? 3. Does that make sense? So when in doubt, figure it out. So this almost looks like, the Tin Man, right, in The Wizard of Oz. But when I put it like that, I can see these circles are the same. And, do you agree the heights are the same? Because, you're just going to have to trust that these heights are the same. And so I just want you to know this is water. And I am not careful. And but it will dry. And I've done this before, so okay. Do you agree when you look at that, it's about 1/3? I mean, it seems to me like it's about 1/3. And so I'll fill it one more time. Actually, first hour it hydroplaned on me. Do you know what that means? Oh, getting less and less careful. And so there's 2 of them. Does it look like it's about 2/3 full? And then I have to be careful on this last one because, yeah, it's gonna go all over. It's going to spill out on me, and so I'll hold this with my left hand and pour with my right hand because that's been my problem. I'm using both of my hands and I shouldn't be. And there it is. Perfect. It works out that the volume of 3 cones is equal to the volume of 1 cylinder. Yay! And I'm just going to dump some of that in there because otherwise it's just so much of a mess. So I just love to do, just my little math thing. And so just to remind us that pi r squared is the area of a circle times that height, but 1/3, because this cone actually takes up 1/3 of the space that cylinder would take up, that has the same radius and the same height. And a sphere, which is that kind of, almost 3-dimensional circle. It has a surface area and a volume formula as well there. And so those are things we're going to use. Now, we start this lesson by writing a lot of things. And you're so lucky that you're 6th hour. So if somebody in 1st hour is listening to this one, they're going, oh, wow, I'm not in 6th hour. But 1st hour, I did not realize that, because I have a new curriculum this year, and I did not realize that I did not give people enough room to write all these in. Okay, so we're going to write everything for this letter A one, but I'm going to tell you if it kind of goes over into B, don't worry a lot, because we're not going to write all the B answers. Or if you have it glued in your notebook and you have a little room over this way, you might want to write some things, parts of the answers there. And I'm going to tell you this, so weirdly, I'm looking at it through the back, and I'm like, I gave the most room for C, and it has the least answer. Of course I did, because I wasn't, being careful, or I didn't know. And so I will actually do my little note to self. So this is 1/8 handout. 1A needs more space. Okay, so that's that, because these are not hard to answer, but there is a lot to answer. And so I'm going to point to you, and you're going to tell me things, and then I'll repeat it as we go. Determine whether the solid is a polyhedron, then identify the solid. If it is a polyhedron, name the bases, faces, edges, and vertices. So give me a head nod. Is it a polyhedron, yes or no? Okay, what's it called? Yes. And I'm just going to write yes, rectangular prism. Okay, and then it says name all these things, bases. So we'll start with bases. Since it's rectangular, we could use, any two sides that are opposite each other as the bases. I'm going to use the top and the bottom, okay? So we're going to use the top and the bottom. When you tell me the bases, you're going to tell me the word rectangle and then 4 letters. And we're going to use the top and the bottom. So I'm going to give you a little preview. You're going to say rectangle, dot, 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 and then rectangle, dot, 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 dot. You with me? Okay, wait. Okay, yeah. The first one, let me repeat the first one. The first one is rectangle, GEFH, correct? And the second one is CABD. So the bases, oh, wow, I'm erasing. My bad. There we go. And I might not say it in the same order you did because now I've kind of forgotten. So rectangles, GEFH, GEFH, comma, and CABD, CABD. And I'm only writing the word rectangle once because let's face it, once a rectangle, always a rectangle. And if I change shapes, I would write that name of the shape. Then next I have to give all of the faces. Do you agree there are 6 faces here? Give me a head nod. 6 faces. And these 2 that we just named are some of the 6 faces, and they are all rectangles. So we're going to say rectangles, and I'm going to go GEFH, comma, CABD. And I had highlighted those, and I wanted to keep them. I'll use a thinner marker so that we know. Okay, so we've got the top and the bottom all done. And now I'm going to need all 4 of the other ones. We've said the word rectangle, so you're just going to kind of slowly read them to me, and I'm going to, one at a time, and I'm going to repeat them and write them. So where's another face? H, F, B, D is that kind of right side. H, F, B, D. And another one? H, D, C, G is that one. H, D, C, G. Oops. And another one? C, G, E, A. C, G, E, A. And a last one, A, E, F, B. A, E, F, B. And I really meant to do all those all in the same color, so I'll just fix them here. And so there are the faces. Notice we wrote the bases, and then we wrote the faces, and we included the bases again. Then our next thing, and you'll notice I trace especially at the board so that I kind of know which ones I have left for you to tell me. Next thing we're going to do is list off all of the edges. And so we're going to say the word segment for each one and the 2 letters of all the edges. And I'm going to ask you to tell me in sets of 4. Just tell me 4 edges, and then you'll pause, and then I'll write them down. And so the next thing is edges. And so tell me any 4 edges on there. Okay, segment, 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 segment. Okay, and segment GH, segment CD, segment CG, and segment HD. Okay, tell me another set of four. Say it one more time. Oh, BD. Gotcha. Okay, and so segment FH, segment FB, segment BD, and segment EA. Okay, and let me slide that up and then you can tell me the last four. Just a sec. Okay, I'm ready. Okay, so segment AC, segment GE, segment, I forgot what ones they were. EF and AB. EF and segment AB. Okay, so lots of things to list out for that. And then the next thing we want to name there are all of the vertices. And you'll notice to keep track, but if you have to write all these, because it is a lot, but when you write all of these, if you write a kind of in some sequential order, it'll work pretty well. Now we're going to go over the vertices. And the vertices are just all of those vertices that we've had that we name with capital letters. So we'll say vertices. And go ahead and just tell me every vertex you see here. You don't even have to say the word. Okay, so our vertices are just those points where edges come together. So E, F, A, B, G, H, C, and D. And capital letters for the points and just kind of saying them as we go. So do you agree? A horrible amount of writing, correct? But not hard. And you're just kind of looking for it. And so then do you see the next one? It's worse, correct? It has more of everything. And so for this next one, instead of writing them all in our notes, so my response to taking up too much space, instead of writing all those in our notes, we're going to say all of the answers, and we're only going to write like the first answer or two. So give me a head nod. Is it a polyhedron? Yes or no? Is it a polyhedron? Okay. And then could you name it for us? What's the name of that polyhedron? A hexagonal prism. So hexagonal prism. And now we're going to name all the things, and I'm going to trace them, but you're not going to write them down, okay? So the first thing I want is the two bases, and they're hexagons. So do you see where those two bases are? The hexagons on that picture? Okay, so you're just going to say the word, for the bases, the word hexagon, and then just go right around it. Go ahead, tell me one of the bases. Okay, and the other bases. Okay, so the two bases are hexagon KLMNOP and hexagon EFGHIJ. Then next we need to list all of the faces. And so we know all the faces, we would say those two, we're not going to repeat them. And then I need all of the rest. I, yeah. You went a different direction on me. So I have to repeat all those, so I'm just going to write it. All of the faces then are still those hexagons, K, L, M, N, O, P, and E, F, G, H, I, J. And then the rest of the faces are rectangles. I can't remember where you started. Maybe L, F, G, M. Uh, and then N, M, G, H, and O, N, H, I, and P, O, I, J, and K, P, J, E, and maybe, did we say that last one? I don't remember. Yeah, I know. Now that I'm tracing them, I think we didn't. So what's that last? Oh, did you? Oh, you maybe said that one at the very beginning. So yes, I think you did start with up there, KLEF, or KLFE, excuse me. And so those are all of the faces. Then we need the edges. And so go ahead and tell me all of the edges. And just the word segment every time. Give me 6 of them to start with. Okay, so some of the edges are segment KL, segment LM, segment MN, segment NO, segment OP, and segment PK, another set of 6. Okay, segment EF, segment FG, segment GH, segment HI, segment IJ, segment JE, and the last 6. Okay, segment KE, segment LOF, excuse me, segment LF, segment MG, segment NH, segment OI, and segment PJ is all of those. And then last but not least, we need all of the vertices. Go ahead and tell me all of the vertices. Okay, so K, L, E, F, J, M, P, G, I, H, N, and O. I don't think I did that in the same order you did, but at least I think I have them all. So that is naming everything, and we just didn't write them down that time because I don't think we had a lot of space. Head nod for this. Is this a polyhedron? It is not. It is not a polyhedron, but it still has a name. What's its name? Cone. And so we'll write no and cone. Now, the tricky thing for this one is we can't name all of those things, but I want to name the things that we can name. So it has a base, and we can name the shape of the base. What is the base? Circle, and its name would be what? T. So the base is circle T. And faces, just give me a head nod because you're keeping answering for this one. Does it have any faces? No. Does it have any edges? No. And does it have a vertex? What is it? It has one vertex that is W. Vertex is W for that one. Okay, so that gets us kind of some information about those as we go. Then we want to be able to find surface area and volume of a few things, and I think our first one is a cone. So I'm going to ask people to read to me the formulas for surface area of a cone, and then we're going to plug things in as we go. And I have some slides here for later. Okay, first of all, I'm going to ask you to look at this picture, and I like to, as you know, it helps me get things right. I like to write down what's the information I have here as I look at this. And a cone also has a slant height. Oh, there's my cone. The cone always also has kind of that slant height L that goes along the edge. So it has two heights, the height from the bottom middle to the vertex, and that's the height, which is 4 centimeters. Whoops. And the radius of the circle is 3 centimeters, and then this slanted height L is 5 centimeters. And to me, if I identify those, then I write my formula, then I know kind of what's happening as I go through this. And so I need to know now how to find the surface area of a cone. What's my formula? Okay, S for surface area, and then go ahead and do this also. Just tell me what the actual numbers are going to be. Okay, and take a minute, get that. And we're going to round to the nearest, I forgot what I rounded to earlier today. We'll just round to the nearest tenth. And I can't find my notes, so I don't even know the answer. Oh, just kidding. I found them. Yes, to the nearest tenth. And what did you get if you round that to the nearest tenth? 75.4. And the label will be what? And it's an area. Yes. So you're taking centimeters times centimeters there, centimeters times centimeters. And did you use the pi key? Okay, in this one, if you use the pi key or 3.14, either of which is fine, you get the same answer as you go. I now need the formula for volume of a cone. Of a cone, though. Yeah, 1/3 pi r squared times height. And then go ahead and put those in for me. So tell me the numbers. Okay, and get that volume to the nearest tenth also. And for this one, I'm just going to tell you if you use the pi key or 3.14, you get the same thing. Do you have that one? .7 centimeters cubed. Oh, and that will wrap it up for today. Let me stop recording.